In this video, we are going to compute a limit using sigma notation. So here we have a problem. Let's say compute this limit as n approaches infinity. The first step is to express this summation in closed form. So in closed form. What does that mean? Just in terms of n. No sigma, no counter, no I. So let's go ahead and do it here. I equals 1 to n 2i over n times 2 over n. So this equals what? What I'm going to do is I'm going to simplify the expression that's inside the sigma notation. That means I'm going to multiply these together. So 2 times 2i, that's 4i, divided by n times n, which is n squared, which I can rewrite this way. I equals 1 to n 4 over n squared times I. It's exactly the same thing. But why do I do that? Because this expression here multiplies I, and it doesn't contain the counter, of course. You never pull out the counter. So I can take this out of the sigma sign, and it becomes 4 over n squared sigma I equals 1 to n times I. So that's what I have, which is the same as 4 over n squared what's in yellow here, it's a usual formula that we have seen before. So what does that equal to? It's equal to n times n plus 1 divided by 2. And at this point here, if there is some simplification that we can make here, we can go ahead and do that. So we have 4 by 2, we have 2, and then n squared n, we're left with n. At the end of the day, we are left with 2 over n times n plus 1, which is the same as 2n plus 2 divided by n. So this is the closed form. There is no sigma and there is no I. But remember, the problem says compute a limit. So the next step now is to compute the limit of the closed form. Limit as n approaches infinity of 2n plus 2 over n. So this is equal to limit as n approaches infinity. You take the expression that has n with the highest exponent. On top here is 2n, and on the bottom is n. And you can see that you can cancel out the n, and at the end of the day you're left with 2. So this is the final answer. That's the limit that we're looking for. Now to practice, I'm going to give you this problem to work on. So problem. Compute limit as n approaches infinity of summation I equals 1 to n of 8i divided by n squared. Remember, the first step is express this summation in closed form, simplify, and then compute the limit.